According to the National Bureau of Economic Research in Cambridge, the introduction of steam engines in the United States increased labor productivity by an average of 25% in small factories and by 45% in larger ones. Yes, those very steam engines that fueled the Industrial Revolution had such an effect. And as a child, I always wanted to find myself at that time to experience industrialization and progress around me. Well, my childhood dream has, in a way, came true. Today, we are witnessing a revolution in AI, allowing us to achieve comparable increases in the personal effectiveness of intellectual workers, and all this without significant capital investments and changes in processes. And that is what we'll discuss. My name is Igor, and let me first tell you a bit about myself. I started my career as a machine learning engineer at one of the leading food retailers in the CIS region called X5 Retail Group. There, I worked on optimizing promotional campaigns, and if at some point in time you saw attractive yellow price tags with discounts, chances are I had my hand in them. Then, I moved on to data analysis at Yandex, a corporation known for operating the largest Russian search engine. Yandex is often referred to as the Google of Russia. At Yandex Market, I began working on product matching, that is, an automatic system for finding identical products on competitor platforms. These skills came in handy when I worked at AliExpress, where I made a career move and became an engineering manager. And currently, I am working as the head of artificial intelligence department at Unleashing.ai. We are a small, biodynamic machine learning consulting agency that deals with the full cycle of AI product development, from system design to implementation. When I was still working as an engineer, rather than preparing presentations and writing dozens of proposals, I managed to earn the title of master on the Kaggle platform by winning 1 gold and 2 silver medals. This is a platform offering machine learning competitions where thousands and thousands of participants from around the world compete for medals and prizes, striving to train the best models. At my peak, I ranked 382nd. In addition to engineering, as I progressed in my career, I gradually started writing articles, reviews, and analysis on my blog at Haber. Haber is one of the largest and most influential technology websites in the CIS region and is essentially the equivalent of Medium. This spring, I became the highest rated author of the platform. Around the same time, I launched my own channel about technology and AI and have already gathered about 30,000 interested readers. There, among other things, I also publish my technical lectures. Additionally, one of my followers on Twitter is Dr. Matei Zaharia, the CTO of Databricks and creator of the Spark engine. Currently, this remains perhaps my biggest achievement. I'm joking, of course, but we'll come back to this later. So, you're probably wondering what I'm going to talk about today. My presentation is titled Opportunities in AI for Practitioners, and first off, it would be good to clarify what I mean by AI, so there is no misunderstanding. That's where we'll start. This will allow us to address the question how to look on AI tools, which will be covered in this presentation as well. After that, we'll delve into real research and examples to understand how this technology impacts our productivity and what this means for you as a company's CIO. We'll explore insights from working with AI tools and figure out the limits of their applicability. And at the end, I'll propose a plan consisting of several specific actions that will help you stay engaged with the 21st century efficiency revolution. So, let's get started. What do people imagine when they hear artificial intelligence? Well, some might picture the Terminator and all associated threats. Others might recall the little clip from Microsoft Word and say, hey, that was the first real AI for the mass consumer. Seasoned engineers might recall a meme that mocks a significant portion of what is sold under the guise of AI. As humorous as this might seem, the last image is closer to the truth than others, and it's not even a joke. It's a decision tree based on if-else rules, and yet their composition or ensemble often yields results. For example, such models are widely used in ranking news feeds, advertisements, and in the banking sector. And all these examples are more related to machine learning rather than true AI. What raises fewer questions are products and technologies that use neural networks under the hood. Even experts are less embarrassed to call these AI for general audience. Examples include filters in photo editing apps that redraw a photo in different styles. Another example is DeepMind's AlphaGo model, which sensationally defeated the world's Go champion. Isn't that true AI? And is it what you expected to hear about in this presentation? So in reality, there has been a lot of noise around the term artificial intelligence, so it is very important to precisely define what I mean by it and how it should be understood. The same actually applies to the recently emerged alias Gen AI, or generative artificial intelligence, but that's a story for a separate lecture or a presentation. So, I propose the following framework which will help clarify our understanding. We'll consider two axes. The first, a vertical one, represents the method of creating AI. There are two primary approaches: manual coding and training using various methods. The key difference is that the first is a linear result of the work of some number of people, while the second depends linearly on the amount of data and compute resources, meaning it can scale without human involvement. The horizontal axis describes the boundaries of the technology's applicability. Generally, more groups could be identified, but let's focus on these two. Narrow AI, which solves one or several specific tasks. The resulting system is tailored exclusively to what it was trained for. The second group on the horizontal axis is general purpose AI, that is, models capable of generalization and, to some extent, reasoning. I won't provide a precise definition or delve into details, but remember, our goal is to gain an intuition that guides our thinking. An example of narrow AI that was manually hard-coded is the Deep Blue system, which defeated Harry Kasparov in chess in 1997. It didn't have advanced algorithms, and many moves were calculated in advance. Clip It from Microsoft Word also falls into this category, and it's essentially a dumb bot with very limited functionality. It's not an AI. Please note that it's still unknown whether it's possible to create general AI, or AGI if you prefer, through hard coding. But that's not really our focus here, and it's definitely not what we are discussing. The already mentioned AlphaGo and the Gen AI representative Midjourney for image generation fall into this bottom left quadrant. These models solve a strictly narrow range of tasks, and you inherently know what to expect from them. For instance, I'm certain that Midjourney can't solve a mathematical problem simply based on its architecture. Although this quadrant is attractive for discussion in terms of opportunities in AI, we'll also ignore it today. And finally, the cherry on top, which can be fully termed AI without reservations, includes models like ChatGPT or Claude, which can potentially solve a wide spectrum of tasks. And neither the solutions nor even the tasks for your specific needs were predefined by a human. It's precisely these technologies from this quadrant that we'll talk about today. I made this long digression to set the boundaries of our discussion very precisely. I believe that models from this rectangle significantly differ from the others mentioned, and this will help eliminate irrelevant criticism regarding the applicability of the technology. Let's take another look at this cell. It's the general AI column. Understandably, the measure of generality is not binary. You can't say that all models are in the same level of generality. It's a spectrum. So different models lie in different parts of this spectrum. The higher the point on the scale, the more general the corresponding model is. For instance, I have placed ChatGPT, released about a year ago, slightly below the midpoint of our spectrum. Let's add a timescale horizontally in addition to the technology axis. We'll also mark a point corresponding to GPT-4 model. It was released later, and it's more advanced. Now, let's draw an abstract line of technology development over time. This is the first key thesis that's important to emphasize. In just a year, we have already seen the first iteration of technology development. Unfortunately, many people tried ChatGPT at its release or even just saw screenshots on social media. They became disappointed in it and stopped paying attention. They never tried GPT-4 and, more importantly, failed to notice the improvements. Okay, you might be wondering, how far can this technology develop, and from what point should it start being implemented in business and used personally? In my view, there are two main scenarios to consider. The first is that both models are at dawn of technological development, and an incredible journey lies ahead. In this case, it is clear that the technology demands attention. This is an obvious case. The second scenario is that the models are already at the twilight of their development and won't improve much further. Perhaps this worldview is what prevents people from starting to use the technology. In the second part of the presentation, I'll try to show that this is an inappropriate viewpoint and it should not become an obvious obstacle. In summary, we don't know how these points are positioned, what the technology development graph looks like, and what the future holds. But I claim that this doesn't matter, and value can be derived from it right now. Let's see what the technology is capable of today. What you see is a demo from the startup adept.ai. Their goal is to create a browser agent that can perform complex tasks based on simple text descriptions. For example, here, the neural network looks at a web page like a human does and tries to understand where to click and what values to enter to achieve the goal. None of the actions, except entering the initial text query, were performed by a human. And, as you can see, the model successfully finds an apartment with 3 bedrooms in the desired state with the specified budget. Pretty cool, huh? An important note about the generality of the model here is that it wasn't trained on this website. Moreover, the model wasn't specifically trained for this task either. It might have encountered different actions on other websites or might not have been trained for this site navigation task at all, especially in the case of GPT-4. Due to its generality, the model can work with any website designed for human use. Okay, at this point, you may think, wow, artificial intelligence is really here, and you might even come up with a couple of startup ideas where this technology could be applied. What I have noticed is that this kind of wow effect often happens when scrolling through LinkedIn or Twitter feeds. It's very easy to deceive ourselves into thinking that the technology can do everything. Unfortunately, it's not all rosy. Here's what they won't tell you on Twitter. According to studies, in a specifically created web environment that the model can interact with, successful end-to-end task execution occurred in only 15% of cases. And all these impressive demonstrations are rare cases when everything works as it should. Therefore, it is important to set the right expectations for the technology, and we'll talk more about that. But why does this happen? Why does the model sometimes work and sometimes not? And how can we leverage this knowledge to use these models effectively? To address this, let's try to identify the main limitations of current generation models. The first, and in my opinion the most significant one, is moderate reliability. You might have heard that the model can hallucinate, meaning it will confidently state things as if they were facts that are entirely made up. The model is also poor at math, makes silly mistakes, and so on. What we want is confidence that if we check the answers for 10 questions in your domain, then the 11th and 12th and so on will also be correct without having to verify each time. But you got to understand, it's often with machine learning that it's an 80, maybe 19% success story, and the model just might miss it. So, reliability is the main bottleneck for these models on the path to becoming useful. On the slide, you can see a screenshot of the GPT-4 page evaluating the accuracy in answering questions. In almost no category does the best model reach 80%. In other words, it's definitely too early to use ChatGPT as a Wikipedia replacement. However, it's easy to see that compared to models from the previous generation, from 2022, the changes are colossal, and they are happening right before our eyes. Two more important limitations to mention are that models possess mediocre reasoning and lack reflection. In terms of real-world intellectual tasks, they are still weaker than the average human, and often fail to notice and correct their mistakes. To be fair, there are also humorous situations where the model changes its tune on the fly when it notices an error. So, what conclusions can we draw from the described examples and issues? Models cannot solve complex problems due to reliability issues at each step, as well as the inability to plan and reason. In other words, they are good at doing some tasks, but not whole jobs. This means we need to shift the paradigm and think of them as copilots and assistants rather than workers. They are merely tools, much like a calculator or Microsoft Excel, helping employees do their job. Even if you look at viral cases involving ChatGPT, it appears more as an assistant's work. You might have heard the story about how GPT helped save a dog while the vet couldn't diagnose the problem. However, what actually happened was that the owner fed the analysis and problem description to GPT-4, and it made a guess about what it could be. Then a real vet validated this idea, realized it could be valid, and ordered additional tests which confirmed the diagnosis. A similar story happened this year with a child whom over a dozen doctors could not diagnose. But once a hint from the model appeared, it became clear which direction to pursue, and this helped. However, the final decision and management of the treatment process remain human responsibilities. These two cases illustrate how I envision using the tool and how I recommend you and your employees to use it. Don't expect the model to do everything for you. It can only assist, increase efficiency, and streamline processes. Humans remain the central component of the system, and there is no talk of replacing them. A copilot merely helps to look at a problem from a different angle, or gives a good start to ensure key aspects aren't missed, and can help due to its broad knowledge base. So after all, we must admit these models generally know more than anyone else. So let's summarize. First, we are talking about general purpose models, not tailored for specific tasks. Second, they have reliability issues. Third, we consider them as copilots and assistants that do tasks, not jobs. And fourth, I spoke about how it doesn't matter where we are on the technology development curve, because benefits can be great right now. So let me try to convince you of this. In the last 6 months, experts from around the world have been exploring how to increase the efficiency of people using copilots. On this slide, you will see 4 studies analyzing this topic. The first and earliest is an analysis by GitHub on how Copilot boosts the productivity of programmers. It was found that the time spent on coding tasks was reduced by 50% because the assistant handles most of the routine and simple parts of the code. Please note that the authors are affiliated with Microsoft, so healthy dose of skepticism is justified. However, this does not apply to the other works I'm going to mention. In the second study, researchers from Princeton and the University of Pennsylvania analyzed the impact of conversational assistants like ChatGPT on specific industries and tried to understand which parts of their work could be automated. I highly recommend checking it out via the provided link. The work from MIT examines increased efficiency in the context of mid-level professional writing tasks, which many of us, to be fair, encounter on a daily basis. And the last, and in my opinion the most important and illustrative study, is a joint research by Harvard Business School and Boston Consulting Group, one of the world's largest management consulting firms. We'll delve more into this study, but interestingly, all the mentioned research comes to roughly the same conclusions, which we'll discuss later. Let's dive into the details of the study. Initially, a set of 18 tasks was prepared. There were creative tasks like propose at least 10 ideas for a new shoe, analytical tasks such as segment the footwear industry market based on users, writing and marketing tasks, and persuasiveness tasks, say pen an inspirational memo to employees detailing why your product would outshine competitors. As you might notice, all these tasks were presented in the context of working with a fictional shoe company. The authors of the research even consulted a real shoe company executive to ensure that the tasks chosen were realistic, and indeed they were. Then, 7% of the company's consultants were selected for the experiment. This might sound minor, but it's actually over 750 people. I'd say this is the largest study I've seen on the use of ChatGPT in real work settings. Also remember, we're talking about the real consultants with genuine experience in similar projects. These are well-educated individuals with problem-solving mindset. These consultants were then evenly divided into 3 groups. The first group did not use AI for the given tasks. The second group was given access to GPT-4, the same model available to all of you for $20 a month. No secret technologies involved, as you might see. And for the remaining group, access to the model was also provided, along with a supplementary prompt engineering overview. So, what do you think? Did the second and third groups perform better than the first? And if so, by how much? If we visualize the distribution of average ratings for all tasks, scored from 1 to 10, we get the following picture. The green group, or those who use GPT-4, achieved on average 40% higher quality results compared to those who completed the task independently. Again, that's a 40% improvement on tasks assessed as relevant to the daily work of consultants. This is an incredible indicator, and it's possible to boost this slightly more with an introductory overview, as shown in red on the chart. You might think that perhaps the consultants didn't take their work seriously, though this doesn't explain the difference with the control or dark blue group here. However, to ensure genuine engagement and effort from participants, the authors incentivized their performance in the experiment through financial implications related to their annual bonuses and additional office recognition. But still, if we assume they weren't sufficiently motivated, it means that these interested and lazy employees performed much better. So let's admit it, such employees are often encountered at work, and if they can significantly improve the quality of work while remaining disinterested, then we all win. Isn't that wonderful? But it's not just the quality of work that significantly increased. Time in the experiment was also limited, and some participants failed to solve all 18 tasks. Those who used GPT in the same amount of time completed on average 12% more tasks, and the average time to complete the entire task decreased by more than a quarter. This means that far more people were able to complete it within the given time limit, which undoubtedly affected the final evaluation from the previous slide. Although these figures are impressive, I think this is not the most important conclusion of the study. Let's take a look at the next chart. All the participants can be divided into two equal groups, bottom half and top half skilled participants. Skill level was assessed based on testing, which included tasks similar to the ones mentioned earlier. This is referred to as the baseline task on the chart. For those in the bottom half, the increase in score on task when using ChatGPT was 43%. For top half skill consultants, this increase was only 17%. It is important to note that their base skill level was significantly higher, and even with this smaller increase, their final quality was higher. But the gap narrows considerably. And this is an effect that was observed in other studies mentioned earlier. The greatest quality improvement is seen in employees with below average skill levels. Thus, it acts as an equalizer of skills. Observing these outcomes, I believe that the significance of technology that elevates all employees to the upper half of performance isn't being fully appreciated by many. Skill leveling is going to have a big impact. Let's switch to a different topic. AI is weird. No one actually knows the full range of capabilities of the most advanced large language models like GPT-4. No one really knows the best ways to use them or the conditions under which they fail. On some tasks, AI is immensely powerful, and on others, it fails completely. And unless you use AI a lot, you won't know which is which. So let me introduce you to the concept of the jagged frontier of AI. Imagine a fortress wall with some towers and battlements jutting out into the countryside, while others fall back towards the center of the castle. That wall is the capability of AI, and the further from the center, the harder the task. Everything inside the wall can be done by AI as of today, and everything outside is hard for AI to do. The problem is that the wall is invisible, so some tasks that might logically seem to be the same distance away from the center and therefore equally difficult are actually on different sides of the wall. In this image, the blue line represents the wall, and the gray dashed line points to tasks that seem equally challenging to us, humans. But our own perception is not calibrated in relation to AI, so tasks that on the same difficulty might lie inside or outside the frontier. Now, an important comment. The efficiency improvements shown in the previous slides are achievable for tasks within the frontier. But what happens if we take on a task beyond it, one that ChatGPT cannot handle? Then we get the following graph. It shows the percentage of correct answers in a complex task where there is a right answer and the task involves analyzing interviews from company insiders and an Excel sheet with financial data. People without AI help had a correctness of 84%, while those using ChatGPT got it right only 60% of the time. This drop in quality can be mitigated by conducting an overview section. The authors refer to this phenomenon as a falling asleep at the wheel, where one becomes too reliant on AI assistants. Thus, it's crucial to view ChatGPT as a copilot and assistant rather than a worker. Every user needs to build their own sense of the technology's frontier, understanding where the boundaries of the model's capabilities lie. In other words, and this is a crucial takeaway, possibly the most important from the entire presentation, nobody knows the best use of AI for your use case. There is no instruction manual out there. The good news is that by using it a lot, you can figure out the best way to use AI. You can't delegate this work, and that's why in this presentation I have tried to avoid mentioning specific tasks so as not to skew your perception. Constantly working with the tool, you'll develop good intuition. Remember, it is a technology that rewards experimentation and use in creative ways. Even if you're a leader or a manager, all these tips apply. Yes, sometimes the assistant will make mistakes and you need to be vigilant. But other times, it might completely handle a task for you. Through practice and developing intuition, you will likely become one of two types of users. The first type is the centaurs. They have a clear line between person and machine, understanding exactly what work they delegate to tools and what to do themselves. In other words, they switch between AI and human tasks. The second type of user is the cyborgs. They kind of blend machine and person and intertwine their efforts with AI, moving back and forth over the jagged frontier. This style of work is common when using ChatGPT for writing. You might ask it to draft something, then make some edits, then ask for a revision, and so on. Well, it's time to sum up. After everything that's been said, it is essential to understand what to do in order not to fall behind the vanguard of technology. I have divided all the recommended actions into 4 groups. The first group is about you as a professional. Start practicing with technology today and make sure to use the most powerful AI assistant available. This will allow you to start sensing the frontier's boundary as quickly as possible. Learn the common prompting techniques. They will help you fully utilize the model and increase the chances that the model will handle the task for you. And the third piece of advice, initially focus on optimizing the quality of work, not the time spent. Don't hesitate to write long, detailed prompts, update them as errors arise, and add examples. You can read about all the nuances of prompting, from basic to advanced, on the internet. I can recommend promptingguide.ai, which contains a wealth of information presented in the accessible form. I have even contributed a couple of articles myself. In general, the golden rule of prompting could be formulated something like, what would you tell a task contractor if they can't email you back? Include detailed instructions, corner cases, and so on. The second group of tips is about you and your team. First, I recommend familiarizing yourself with all the details of the 4 studies presented, how and what was measured, where the increase in work efficiency came from, and how applicable it is to your work. Once you are convinced of the study's validity, secondly, share this presentation with your colleagues. Help them realize the necessity of starting to master technologies early, as well as thinking of AI as a copilot or assistant. This is a very important insight that many overlook. Then, try to lead by example and show your colleagues how AI can be used within the scope of your department and your responsibilities. The third group of recommendations is about actions at the level of your company. I have emphasized several times how important it is for you to start using new tools and assess their applicability limits independently. Trust me, no blog post or video can substitute for your own sensations and the aha moment that just has to happen. Once you understand and feel the technology's frontier, help those around you, your subordinates and colleagues. For instance, in our company, we have a 1-hour bi-weekly meeting for knowledge sharing. You can even host a hackathon to incentivize this process, but honestly, I don't think this is necessary. And the final group on the slide consists of just thoughts from top of my head. If you decide to automate a specific part of your work, such as drafting ideas on a given topic, make sure you have tests for the model's adequacy. ChatGPT and similar neural networks often undergo retraining, so their behavior might change over time. Our friend from one of the first slides, Dr. Matej Zaharia, along with colleagues from Stanford and Berkeley, wrote a paper exploring this issue. It clearly shows that some automation scripts simply would stop working because the model's response format changes over time, making it impossible to parse. After all, you don't own the product through the API, and it can be regularly updated without a notification. And the last two reminders. Don't forget that we are on a trajectory of technology development, and although no one knows exactly what lies ahead, we need to plan for the future. The problems that models have now will disappear in 2, maybe 3 years, and you will be left with valuable skills. So, as a CIO, your task is to provide the necessary training and resources to ensure that your team can effectively navigate this jagged technological frontier. It's essential to create conditions that enable employees to understand when and how to fully utilize these tools. Despite ongoing philosophical and technical discussions about AI's nature and its future, it has already become a major force transforming our work methods. This isn't just another overhyped technology that promises to revolutionize the world in just a few years, or that demands massive investments from large corporations. It is here, and it's impacting us now. Considering the potential for increased productivity, it's crucial for every company to dedicate a substantial amount of their time, starting immediately, to exploring how AI can enhance their performance. We are just at the beginning of the AI era, but the disruption is already evident. There is no guidebook. Nobody has all the answers yet. But the key is to learn quickly and adapt. And that's all from me. You can always reach out to me directly using the contact information provided on the slide, or just leave a comment under the video if you're watching the recording. I'll make sure to read and respond to all of that. Looking forward to our next meeting, and goodbye for now.